Okay, so now back to the pre-lab part of this. So we've done this table. We calculated those. That's to make our standard curve so we can measure what the iron thiocyanate concentration is. But the other calculation it has to do, and this is what you'll be asked to do for each of the solutions, A, B, C, D, and E, I believe, in this, is calculate initial molar concentrations. That's what we just did of these. And then what's the change at equilibrium? So what this is. So that's I've got to fill in this table, and it's going to give us some amount. And I've just transferred that over to, this is the amount you're given in that question 3. So I'm going to have 5 milliliters of 0.2 molar iron 3 plus, and it's mixed then with 5 milliliters of 0.002 molar thiocyanate solution. And then we make the iron thiocyanate that's colored, and that's been measured, and we measure that, and that's what the concentration is. That comes out of the spectrophotometer. So now we need to know what was our initial concentrations, and that's what this calculation is, right? It calculates the number of moles. We'll divide it by 5 plus 5, so that's 10 milliliters total, and that's our starting or initial concentration. Okay, so now I've just done the next step in the calculation. So these are the amounts of moles, and we're taking 5 milliliters plus 5 milliliters. So our initial iron 3 plus concentration is that 1 times 10 to the minus third molar divided by the 10 milliliters to give us our molarity of the iron 3 plus and the molarity of the SCN minus. Now that's initial, and that's one of the entries you need to make. So we go in here to our table, initial molar concentrations, we put that in for Fe3 plus, we put that in for SCN minus, and then what is the initial concentration before reaction? It's 0. There's none. And then what do we do for the equilibrium molar concentration? Well, that's what's given. So that's the other thing that's in here. So over here we're told that at equilibrium we have 7.2 times 10 to the minus fourth molar concentration of the iron thiocyanate complex ion. So I've written down here, this is the reaction, iron 3 plus thiocyanate produces the iron thiocyanate complex, and our measurement of the absorbance tells us that our concentration, right, is 7.2 times 10 to the minus fourth. Now where does that come from? That comes from one of these to give one of those, and one of these to give one of those. So if we have made 7.2 times 10 to the minus fourth, that has to come from the starting concentration of the iron and the starting concentration of the SCN minus. So that's a subtraction problem. So I'm going to write that down for 1. I'll just do it for iron, same thing for SCN minus, and this is what it's going to look like. So I take my initial concentration, the 1 times 10 to the minus 1, and I subtract off, because it's a 1-to-1 relationship, 7.2 times 10 to the minus fourth. To get out here is my answer for iron 3 plus is going to be 9.93 times 10 to the minus 2 molar. That's my final equilibrium concentration of iron 3 plus. And then the same process for SCN minus, right? In this case, it's 1 times 10 to the minus third minus that amount to give me my final. Now, you're also asked to calculate a delta, a change. Well, that change is the concentration of the final concentration of 7.2 times 10 to the minus fourth, because it's initial plus the delta, and the delta is minus. If we stay with our final minus initial, our final concentration of iron 3 plus is less than our initial concentration, so that's a minus. So it's initial concentration plus the delta equals our equilibrium concentration, and that's what goes back into our table. So let me go pull up that table. Let's see, that's right here. Right, so we've got our initial concentrations that we're filling in. We've got our final equilibrium molar concentration. That's what we just calculated for each of these. And then our delta is equal to that final FeCN 2 plus concentration. And then ultimately to calculate what K is, that's the equilibrium expression. So let me pull up another place to write. So that's all I've done here is just pull this out and okay, so the equilibrium constant K is equal to the concentration of the products, in this case FeSCN, and that's a 2 plus concentration, divided by the reactants. So that's Fe3 plus concentration times SCN minus concentration. Now these are all at equilibrium, all right? So just plug those concentrations, multiply it, and you get your value for K. And that's really all the calculations you're going to do all the way through the lab. That's certainly the calculations you do in the pre-lab. There may be a few other things for you to think about, and I'll leave you to that. But these are the calculations. So take a look at this. If you have any questions, let me know. Send me a text. You talk about them in recitation. If you have these ready to go for recitation, you can get these things all worked out. Okay, good luck.